It's going to be the exam is going to be again on 8th.
Again on 10th of May?
8th of May.
8th of May.
Yeah.
Okay, so you got like time for doing the quick revision and then again you can give the exam. Okay, and
Yeah.
whatever mistakes has happened that you are not going to repeat one more time, right, Arya?
Yes. Yes, ma'am.
Yes. Okay, let's start. Yes. Let me give one question to you all. Please solve it at first, then we will move ahead. P and Q are two positive integers such that P is equals to P cube Q and Q is equals to PQ square, where P and Q are prime numbers what is LCM of PQ? Please do it. Arya, Ifra, this is MCQ question. Abdul.
I was not the last class, so can I get a backup class for that?
Okay, I will inform our operation team. Arya, you let me recall what we have discussed in the previous class.
Okay.
We were discussing the concept of, two important questions also we have discussed. Yes, Arya. I will inform our operation team. However, you also inform, okay?
Okay, mom.
Yeah, we will be arranging. Aisha, Ifra, Abdul, Arya. This is the question. The first question, Aisha, I have written it over here. We are continuing the same topic. At first, I have not started the class yet. I have just written this question. Read this question carefully, everyone, and try to solve it. Take 1 or 2 minutes to solve it. Then we will be discussing it over here. Okay, Ifra, Abdul, Aisha, and Arya. Let me know which option is the correct option. Are you done?
Yes, mom. I sent the answer in the chat.
Okay, let me check. B. Arya has already responded. Ifra, Abdul, Aisha. Let me know what are you getting. We will be doing it quickly. Aisha is saying option B. Ifra, A. Okay. Abdul, I am waiting for your response, Abdul. Either you can unmute yourself or you can write it in the chat box. Abdul, are you doing it? Still doing it? Then I'll give you more time. Okay, do. Arya, I change it to A. Abdul is A. Okay, everyone is saying A. Let me check. Abdul A, Arya A, Ifra A, Aisha B. Okay, let's check. This is what we are having, and we have to find the LCM. We already have understood the concept of LCM, the process of finding the LCM. So P is PQQ. Q is PQ whole square. This one can be written as, it can be written as, like, let it be like that for now. Okay. The other one, we can apply the rule of exponent, the law of exponent, which says that whenever two terms are in multiplication, and if there is a exponent, like bracket is there and then the exponent is there, we need to distribute the exponent. It will be p square into q square. Okay. This is applicable for only multiplication and division. Let me tell you, it is not applicable for addition. If you are having a plus b whole square, please don't write it as a square plus b square, because that will be incorrect. We can only write when a into b is there or when a by b is there. A square, B square, we will not be having in the case of plus and minus, because that time we have to apply the identity. That time we have to apply the distributive property. That time it means A plus B into A plus B. Okay. If A plus B whole square is there, if A minus B whole square is there, that this is the meaning of that one. Okay. However, if PQ whole square is there, if multiplication is there, then we can distribute the powers. Okay. Now, what is the process of finding the LCM? The process of finding the LCM is, first check what is common. P is here, P is here. But that first P is having power 3, the second P is having power 2. So while writing the LCM, we will always be taking the maximum power. Now the other common part, Q is here, Q is here. Again, we will be taking the maximum power when we are talking about LCM. So it will be Q square. Now what the concept of LCM is? The concept of LCM is, here we are going to discuss in detail. Maybe you have applied the detailed way. So if P is P cube Q, that means P into P into P into Q. And if Q is PQ whole square, that means P square into Q square. That means P into P into Q into Q. Okay. Now, while writing the LCM, what we do? We take the common, all the common terms at first. Let's take the common terms. P is here, P is here. We are going to write that P. One more P is here, one more P is here. We are going to write that one more P. All the common we are writing, and then we are not going to use it one more time. Okay, common one we have used. The circled one, we have used it. We are not going to touch that one more time. Okay, one more P is here, but no other P is there. It's fine. We will, at first we are focusing on getting the common terms. So Q is here, Q is here. So we will be writing Q over here. Once we are done with noting down all the common number, common terms, then we will be writing all the extras. Okay, I'm going to represent all the extras by green color. Okay, all the extras we are going to take by green color. This is extra, this is extra. So 1P and 1Q was extra. What is LCM? Let's do the multiplication of P into P, then Q, then P, then Q. All the P we will multiply together. That we can write it in the exponent form. P into one more P is there, PQ. Q and one more Q is there, Q is square. So if you have applied the detailed method, can you see we are getting P cube, Q is square? Or if you have applied this quick method that we always search the common and then we will be taking the maximum exponent of that, then also we are getting the same answer in both the cases. Can you see? Can you?
Yes, ma'am.
Yes. Ifra, Aisha, Abdul, is it clear now? Answer will be P cube Q square, LCM. What about the HCF? Option C is the correct option. What about the HCF? HCF means we always write the only the common term. Okay? Common term, and if the quicker way you are applying, quicker method you are applying, then that means we just have to write the common term, that's least power we have to write. So if P square is there, and then if P cube is there, this rectangular box. Okay, I'm talking about, just keep on just seeing carefully the cursor of mine. P square is there, we will be taking the lowest power, lowest exponent of the common term, that we have to write while writing the HCF, that is P square. In between P to the power 3 and P to the power 2, P to the power 2 is the lowest exponent, least exponent of P. P square. First one is Q, other one is Q square. So what is the least exponent of Q? Can you tell me? Anyone? If the first one is Q, see this yellow underlined part. This is Q, this is Q square. When we are writing the HCF, we will be taking the least power, least exponent. So we will be taking only Q. Yes or no?
Yes, ma'am.
This is the HCF. However, in this question, we were supposed to find only LCM. If by detailed method we have to find the HCF, how we will do? We will just be taking the common term. Just common term, that means all the circled part. Circled are, you can see P is there, orange color circle, then black color circle, then sky color circle. So that means P into Q. Yes or no? Yes or no?
Yes, ma'am.
I'm talking about this part. Okay? Aisha, Ifra, Abdul, Arya, orange color circle, black color circle, and this circle. That means these are just the common terms and that only we need to take while writing the HCF. So whatever method feels comfortable to you, feels convenient to you, apply that. This approach we have to apply when we have to find LCM or SCF. This is what we were doing when we were finding the LCM or SCF of a number. Yes or no?
Yes, ma'am.
Is it clear to everyone now? Yes, Ifra, Aisha, Abdul. Ifra, yes. Abdul, Aisha. Aisha. Let's take one more question. Question is the largest number. Still you have not answered. Aisha and Abdul, is it clear?
Yes.
Yes. Please let me know once I am asking you. Then only I'll understand, no, whether it is clear to you also or not. Then I will move ahead. Otherwise, I will keep on waiting. Okay? So when I am asking, please let me know. Largest number which divide 70 and 125, leaving remainder 5 and 8 respectively. Okay, this is the question we are going to discuss for now. Option is there 13, option B is there 65, option C is there 875, and option D is there 1750. Okay, the largest number which divides this two number, leaving this 5 and 8 as a remainder respectively. How we will be doing so? So the largest in previous class, Arya, you was not there. I said that in the previous class that if we are having this terminology, that is highest, largest, maximum, that means it is indicating us to find the HCF. Okay, we have to find the HCF in this scenario when in the question these words are there, maybe highest, maybe largest, maybe maximum, and if the word like lowest, least, minimum, these words are there, that means it is indicating us to find the LCM. Okay, so here largest word is indicating that we are supposed to find the HCF. That is fine, that we understood, but which numbers HCF we will be finding? Are we going to find the HCF of 70, 125, 58, all the four number? No, let me explain you. Okay, so the largest number which divide this and this, leaving the remainder 5 and 8, leaving these two numbers as a remainder. So let's say when we are having a number 35, and when we are dividing it by 2, okay, 35, when we are dividing it by 2, let's say 2 1 times 2, 2 7 times 14, remainder is 1. When we will subtract the remainder, now we can say when we are dividing 35 by 2, it is leaving the remainder 1. When we are dividing 35, when we are dividing 35 by 2, it is leaving the remainder 2. It is leaving the remainder, I'm saying 2, sorry for that, that is 1, the remainder 1. Okay, this is what we are getting when we are dividing 35 by 2, it is leaving the remainder 1. What if we will subtract this 1 from the divisor? What is divisor? Let me write it. Let me help you recalling that this is, this is divisor and this is dividend. I wanted to say that what if we will be subtracting the remainder from the dividend, not divisor. Okay, this is remainder. So the number by which we are doing the division, that's called divisor. 35 is the dividend over here. 17 is the quotient. We already know. 1 is the remainder. We already know. We don't get confused between remainder and the quotient. However, we always get confused between divisor and the dividend. So I have written over here. Okay. So if we will subtract 1 from the dividend, dividend is 35. If we will subtract 1 from 35, that is 34. And if we will divide it by 2 now, 34 we will divide by 2. What are we going to get? 2, 1 times 2. 2, 7 times 14. So can you see when we have taken out the remainder or subtracted the remainder, from divisor, from again, again and again I am saying divisor, I mean dividend. Okay, from dividend, when we have subtracted remainder from the dividend, then it is completely divisible by 2. Still, we have not solved the question. We are trying to understand something. That first we have divided 35 by 2 and 1 was the remainder. When we divided 35 by 2, it is leaving the remainder 1. Leaving means giving the remainder 1. Okay. When that remainder we have taken out from the dividend, when that remainder we have taken out or subtracted or excluded from the dividend, then it is completely divisible by 2. Yes or no? Yes or no?
I didn't
Right?
understand.
Yeah.
Ma'am, I also didn't understand.
Just tell me, 35 we are dividing by 2. You have seen that it was completely not divisible. We were getting a remainder. Remainder means extras. Whatever extras was there in the number 35, that was coming as a remainder. That extra, first only we have taken it out. From 35, 1 we have subtracted. Whatever extra was there, that we have taken it out. And then we have done the division. Then we realize that it is completely divisible by 2. Only this much. Is it clear or not?
So we subtract the remainder by the number.
Yeah. Whatever number we are having, whatever at the end, what we get as a remainder, whatever is extra in that number. Okay. Let's take one more example. Just a second. No? Let's take one more example. Suppose we are having a number 78. They are going to divide it by 4. Let's do the division, the basic normal division. 4 1 times 4. 4 9 times 36. What is the remainder? 3. Now what if at first only we will take out this remainder from the number 78? What if at first only we will subtract 3 from 78? Okay, what we will be getting? 75. Okay, here we must get 2 only. I have written 3. It will be 2 only. Can you see? Can you see? The remainder will be 8 minus 6, that is 2. So what if we will, at first only, we will subtract this 2 from our number. That time we will be getting 76. Now you check, this 76 will be completely divisible by 4. Check it. Is it completely divisible?
Yes, ma'am.
Aisha, Abdul, Ifra, is it completely divisible?
Yes, ma'am.
Yes, it is completely divisible. Abdul, Ifra?
Yes.
Yes. Yes, it is completely divisible. So are you understanding? If any number is leaving remainder when we are doing the division of two number, if there is a remainder, if initially only we will take out, we will subtract that remainder, then that number will be completely divisible by the given number. Yes or no? Yes or no?
Yes, ma'am.
Remainder means what? Remainder is 2 extra is there in the number 78. 2 extra is there. That's why we got 2 as a remainder. When we were having a number 35, there was one extra in this number 35. One extra was there, that was coming as a remainder, and that only we have taken it out, then it became completely divisible. Now let's get back to our question. Okay. The largest number means highest common factor, means HCF. We have already realized HCF, highest common factor. Common factor. Common factor. We are talking about common factor. Factor means the number which can divide the given number. Yes or no?
Yes, ma'am.
Common factor means the number which can divide. Okay. Common factor of, if we will write 6, if we will write 12, factors of 6 are 1, 2, 3 and 6. These are the number which can divide 6 completely. If we will list down the factor of 12, it will be 1, 2, 3, 4, 6, 12. These are the numbers which can divide 12 completely. These are the factors of 6 and 12. Factors of 6 and 12. And among these factors, which one is the highest? Which one is the highest and common also? So this one is the highest factor and that is common also. Hence we will say 6 is the HCF. Right? Similarly, in our question, the largest number which divides 70 and 125, leaving the remainder 5 and 8. If we will directly find the HCF of 70 and 125, that will give the largest number which can divide 70 also and 125 also. Yes or no? But what about the remainder things? How we will take in consideration the remainder? So when we are having this question, at first only we will take out the remainder. From 70, we will take out this remainder 5 and that became 65. From the another number 125, we will take out the remainder 8 and that became 117. Okay. Now the same question, we are going to find the HCF of 65 and 117. We are going to find the HCF of 65 and 117. That means we are going to find the largest number which can divide completely 65 and 117. Because already we have taken out the remainder, whatever extra was there, that we have taken out already. Okay, now we can think about which can divide 65 and 117 completely. Which can divide 65 and 117 completely. That means we just have to find the HCF of 65 and 117. Are you getting it?
Yes,
Are you
ma'am.
getting? Aisha, Ifra,
Yes, sir.
Abdul. Ifra, yes. Abdul. Whatever is remainder, we were not sure. how to take LCM also, how to find HCF also, remainder also. HCF means completely divide, factor. Remainder was creating problem because HCF means the number which can completely divide, that means factors. When we are talking about HCF, we are talking about factors. HCF means highest common factor. Here we had to take out remainder. That means at first only taken out the remainder. Now we are on the safer side. We will directly think about the HCF. Clear?
Yes,
Aisha,
ma'am. Yes,
Yes.
ma'am, I got the answer.
got the answer also. Please find the HCF of 65 and 117.
Okay.
Yes, Arya, let me know your answer.
Ma'am, to find the HCF, can we use Euclid's division lemma?
But here we are supposed to use in everywhere prime factorization method, Aisha. In our, according to our NCRT, according to our syllabus, yes, we can find. For this MCQ question steps, we don't have to show, we'll just be marking the perfect answer. Yes, we can do, but every time we'll be trying to use the prime factorization method. Because if you will see your NCRT, that is not there now, right?
I think so it's deleted.
Yeah, it is deleted. It's a like same thing, HCF we can find, but it is deleted. So 70 is there and 125 was there. We have excluded the remainder 5 and 8. That became 65 and 117. Now we will be finding HCF of 65 and 117. Please let me know. Ifra, Aisha, Arya, Abdul. Arya is getting 13. Rest of the student, please let me know your answer. Yes, Abdul. HCF of 65 and 117. Ifra, Aisha. Ifra is getting 13. Abdul and Aisha.
Ma'am, 13.
13. Aisha said 13. Abdul. Abdul. Abdul,
13.
can you hear me, Abdul?
Yes, 13.
Yes. 13 is the right answer. Perfect. Let's move ahead. Now we are having a theorem. Okay. What the theorem says, the other theorem. We already understand what is, first let me know. Do you know what is irrational number? Non-terminating, non-repeating decimal number. Like, do you know the difference between terminating decimal, non-terminating decimal, rational number, irrational number? Do you know that? Abdul, Arya, Aisha, and Ifra. Yes or no?
Yes.
Yes. Abdul, Arya, you have already responded. Ifra, Aisha. Ifra said yes. Aisha, if no,
Yes,
I'll be taking it quickly. Yes or no?
No.
No, let's do it. Yes, you need to tell me. Okay, then only I'll understand my students know it better or not. If not, I'll explain it. Okay. So, decimal numbers are of two types. Terminating decimal and non-terminating decimal. Terminating decimal means there will be a termination. Termination means stoppage. Some, like, a person got terminated from the school, like from the job, from anywhere, from the reality show, anywhere. So that's called stoppage. Terminating decimal number example will be 3.25, 6.73, 8.432. There will be a termination. After decimal, there will be certain number of digit and then it will stop. Number of digit, there can be 2 digit, it can be 3 digit, it can be 4 digit. After a certain number of digit, it will stop. That's called terminating decimal. Now, non-terminating decimal, it are having two types. Non-terminating decimal are two types. First one is repeating decimal and the next one is non-repeating. What are the example of non-terminating decimal? It will not stop. It will not stop. That means it will be in this way: 3.777777777777777 keep on going. One example is that. Another example can be 4.352386732103. So without any proper pattern, there will be an infinite number that will just keep on coming and keep on coming and keep on coming. So these are the example of non-terminating. That means it will not stop. Now that is two types. The first one is repeating and other one is non-repeating. This repeating, this non-terminating, repeating is also called repeating. This one is also called recurring decimal. Other one is called non-repeating, is called non-recurring. Now just focus on the name. Recurring means reoccurring. The number will keep on reoccurring and the example of that is 3.5555 like that. Okay, there will be a specific number of digits which will keep on repeating. Okay, that's the example of the example can be 3.73. You must have seen we write bar on the head. The other one example randomly is 4 point whatever we have taken 72168 randomly without any repetition. Repetition of the digit will be there, but you won't be able to find a pattern over there. That's what I'm talking about. Here you will be getting a pattern. If we are having 3.73 bar, that means 3.73, again 73, again 73, again 73, again 73. So you can see the pattern over here, but there you won't be able to see the pattern, any pattern. Okay, and it will never ever stop also. Now we know that this terminating decimal number is called rational number. Why it is called rational number? Because we can write this 3.25 as 325 by 100. We can write this 6.73 as 673 by 100. We can write this 8.432 as 8432 by 1000. Whatever be the number of digits are there after the decimal, that many zero we are putting, and we are able to write it in P by Q form. Once we are able to write it in P by Q form, that means it's a rational number. That's why we say that terminating decimal number are rational number. Non-terminating decimal number, when it is repeating decimal number like this one, 3.73 or 3.555, that also is a rational number. We have already learned that by 9, by 99, by 999 we'll be getting, we were finding the value of this type of rational number, like x equals to 3.73 bar, and then we used to do the multiplication both side by 100, and eventually we were able to represent it in the form of P by Q. That's why we say that when we are having non-terminating repeating decimal, or the other name is non-terminating recurring decimal number, that's called rational number. What is irrational number? When we are having non-terminating non-repeating decimal number, that's called irrational number, because that we won't be able to represent in the form of P by Q, where P and Q are integer and Q not equals to 0. We won't be able to write. If we are having a random number 4.738256799321, randomly any digit will keep on coming, then we won't be able to write it in the form of P by Q. It is not possible, and hence it's not a rational number. What are the some example of irrational number? Can you tell me? Anyone?
Root 2.
Yes, root 2, root 3, pi. Pi, which we take as a 22 by 7, it is just the approximated value. Approximated, it is not the approximated value. It is not the exact value of pi. Pi is irrational number. Pi is equals to 3.14, and random digit will keep on coming and keep on coming and keep on coming without any proper pattern. Okay, it is non-terminating, non-repeating. Similarly, when we will find the square root of 2 by long division method, we will realize that it is non-terminating, non-repeating. Similarly, when we will find a square root of 3 by long division method, we will find that it is non-terminating, non-repeating. So any number which just got stuck inside the square root, which is not a perfect square, like let's say 6, let's say 7, these are the number which are not perfect square. Whenever we will find the square root by long division, it will just, this type of number we will be getting, like this number. See the cursor, like this number. Okay, that's why we say it's an irrational number. Now we have realized that what is irrational number. Here we will be discussing a theorem, and then here we will be proving. Here we are going to prove that root 2 is an irrational number. But before that, let's see the theorem which we are going to use while proving. Okay, so the theorem is, let P be a prime number if P divides A square. Then P divides A where A is a positive integer. We will try to understand this theorem at first. Okay. Let P be a prime number. P is any prime number, 3 or maybe 2 or maybe 5. Okay. If P divides A square, if 3 can divide any numbers square, let's say 81. 3 can divide 81. Check it. Check it first. 81 is completely divisible by 3, yes or no?
Yes.
Yes. Arya?
Yes, ma'am.
Aisha?
Yes, mom.
Yes. Ifra? Yes. So if P, that is a prime number, can divide a square of any number, 9 square is 81, then 3 can also divide 9. Check it. If P is a prime number, if P divides A square, then P will also divide A. Yes, we know 3 can divide 9. We know that 3 will divide 9. Similarly, if 2 can divide any number, that is a square, that is a square of any other number, 2 can divide 16 completely. We know that 16 means 4 square. Then 2 will also divide 4. Yes, we know that 2 divides 4. Yes or no? Similarly, if 5 can divide a square of any number, then 5 will divide that number also. Okay, if 5 can divide, let's say 625, check it, 625 is divisible by 5 or not?
Yes, ma'am.
Yes.
Then can we say 625 means 25 square? Then can we say 5 will divide 25 also? Yes, we know that 5 divides 25 completely. Yes or no? So what are we
Yes,
getting
mom.
from this theorem? If P is a prime number, if P is dividing A square completely, then P divide A also. Got it?
Yes, mom.
Got it? Okay.
Yes, ma'am.
This theorem we are going to use while proving that root 2 is an irrational, root 3 is also an irrational. But before that, we also need to understand that if we are having 6 and if we will factorize it, we can write it as a 2 into 3. So can I write 2 divide 6? Can I write 2 divide 6? That means 2 is dividing 6 completely. 2 can divide 6 completely. Completely word I am not writing. But we need to understand when I have written 2 divide 6, that means 2 can divide 6 completely. Agreed? Yes or no?
Yes, mom.
If we have written 8 is equals to 2 into 4, then we can say 2 divides 8. Similarly, if we are having, let's say 77 is equals to 7 into 11, then we can say 7 divides 77. Yes or no?
Yes, mom.
So if we are having m is equals to p into q, can we say p divides m? Can we?
Yes, mom.
If we are having k is equals to 2p, then can we say 2 divides k? Can we?
Yeah.
Everyone, are you getting it? Abdul, Ifra, Aisha?
Yes, ma'am.
Abdul, Ifra,
Yes.
getting? Aisha has responded. Ifra, is it clear? Similarly, if we are having, let's say we are having p is equals to 2c, we can say 2 divides p. Yes or no? Yes or no?
Yes,
Now, if
mom.
you have understood this, then if there is a statement, if there is a statement that 3 divides P, can we write P is equals to 3 into maybe anything like X? Can we write? Can we write?
Yes, ma'am.
Okay, if we are having 5 divides, let's say K, so we can write K is equals to 5 into any other number we don't know, so X, Y, Z, anything we can take. Yes or no?
Yes, ma'am.
Yes, ma'am.
If we are writing 11 divide 30, no, I'm not going to take a number, let me take M. Then we can write M is equals to 11 into any other number we don't know, we can take it as a Y, we can take it as a X,
Yes,
we
ma'am.
can take it as any other variable. Getting it?
Yes,
Is
ma'am.
it clear so far? If this theorem and this much part is crystal clear, okay, then we will be proving that root 2, root 3, root 5, these are irrational numbers. I'm not going to take that for now. Yes, Ifra. I'm not going to take it for now because it will take at least 5 to 10 minutes to understand the whole concept completely. Then we need to practice a lot of